everybody. I'm very glad to see you all here. I'm Anna, this is my colleague Christina, and we both work as software developers and IT consultants for Concentric, which is a small-ish company working mostly in Germany, but we also have a nice little office here in Amsterdam. And we're kind of a rather traditional company. A lot of our customers are like big old German companies, and so when we start talking about, yay, JavaScript backends, we get this kind of reaction a lot of the time. They are like a little bit shocked and very, and nah, not really, let's not do that. And today we want to talk about some of the prejudices that we encounter and want to talk about some things that you might want to keep in mind when doing JavaScript backends, and also want to show you some small JavaScript microservices and how to do that. So that at the end of the talk, it's maybe more like, yes, that's a thing that we can do. And so let's get right into it. A lot of the time I hear nobody is doing real JavaScript backends. And I always ask, like, nobody? I mean, what about you guys? Is anybody of you doing JavaScript backends? That's quite some. And there's a lot more, like Netflix and PayPal and NASA. I mean, come on, NASA is doing JavaScript backends. From my point of view, that means it's definitely not nobody doing it. But of course, when you get past that point, there's always the issue of it's only a single thread.
Yeah, it's common to get this response from most people which are used to multi-threading applications. They're like, oh, I can't work with one thread only. So, at first we're going to compare multi-threading with the event loop, which is based on JavaScript, the node event loop. And we are doing it by an example. That's me. I love cinnamon buns. I really love them.
Yep.
And there are two bakeries in my town. One, which are going to bake the cinnamon buns via the multi-threading style, and the other one by doing that with an event loop. So, let's visit the first one. Oh, yeah, there's the event loop bakery. That's the multi-threading bakery. There's me, and there's a nice baker which asked me, what do you want? How can I help you? And I would say, I would like to have cinnamon buns, and I would have at least 20 of them. So I'm going to get 20 of them.
That's not enough.
No, there must be more of them. So the baker is going to start and preparing the dough. Maybe the dough needs some time to rest, so it's standing there and waiting until the rest time is going to finish, and then she will put it inside of the oven, and the oven will ring at some point. 20 minutes later, she's standing always in front of the oven and waiting that the oven will say, hey, I'm finished. And something around 30 minutes later, yay, it's finished, and she's coming to me and said, hey, here are your canal buns, cinnamon buns. You can eat them now. And I would be like, yay, cinnamon buns. And if Anna would join, and she would also ask, I would like to have 20 cinnamon buns, she's not going to ask the same baker. She gets a different baker, who is also doing only her stuff, and is waiting in front of the dough when the dough is resting, is waiting in front of the oven when the oven is going to cook it. And yeah, that's actually multi-threading. For each request, you get her own thread. So Anna gets her own baker, yes. I get my own baker. No problems with that, or?
Perfectly fine with that.
But I also like the other bakery, so I also go to the event loop bakery. But there's only one baker who's doing all the stuff for me currently. But she has a pretty tough schedule. She has timers, callbacks, pause, check, and close callbacks, and that's her schedule. So she's always beginning with, is there still an alarm which said to me, yeah, I should do this task now? No, there's nothing left, because it's the start of the day, nothing there. And then I'm going to enter the bakery and said, hey, I want to have something. But she's like, nope, wrong phase. I'm still checking if there's something to do. So she put me inside of a queue, and I'm waiting now. Then she goes back and saying, oh, is there still something in the oven? So is there still a callback there? No, there's nothing. OK, then I'm fine. So we are going to get to the poll phase, where I, as person, can finally make my request. So she's going to ask, how can I help you? I would say 20 cinnamon buns. And she would be like, yeah, OK, I'm fine with that. And going to start to prepare my buns. Then she would say, okay, the dough needs to sleep at least for 10 minutes. And yeah, she would put it in a timer and wait. Then she would say, okay, now I can do different stuff because there's nothing left. Is there something which I must make now? No, there's nothing. There's nobody which I must say goodbye at the moment, so okay. At some point, we are back in the timer. So my timer has said, hey, I'm finished. The dough is finished with resting. I could do something different with it. So I'm getting the dough, and it's time to put it in the oven. And yeah, we put it in the oven, and the oven is doing his stuff, preparing, cooking. And so she could do something different during the time and put it in a queue. And luckily, I have a really fast oven. So it's finished like 1 minute, which is not in real life so, but this oven is really fast. And then she's back to the oven, gets the cinnamon bun, goes to me and say, hey, your cinnamon buns. And I am happy because, again, I get cinnamon buns. And yeah, but I couldn't say goodbye because my connection is still open. So I need to wait again until she has the time to say me goodbye. Maybe there are other persons like Anna who come enter the bakery and say, hey, I want to have some cinnamon buns. Then she would do it there.
40 cinnamon buns.
60.
Okay.
Is there something I need to do now? No? Okay. So it's finally, she can say me goodbye, and I say goodbye, and I'm going to leave the bakery. So the main difference between the event loop and multithreading is we have just one person who's doing the stuff in most cases. We could make more persons who are doing the stuff, but that's in our control if we are going to do that or not. Yeah, and now, so we have both of them. Let's start with the bad things. There are disadvantages. If you're going to use heavy calculations, tasks like preparing a wedding cake, making the decorations, which you can't split up, for example, so that you get a really long blocking task. So you cannot split it up in any case. Then we might have a problem because then Anna doesn't get served. And she wants to have some canal buns and don't want to wait something like 6 or 8 hours for that. Yeah, we actually can split up onto multiple cores, but it's not happening automatically for us. So we need to take self-care about this. In a multi-threading application, yeah, the thing would just see, hey, there are more cores, so I'm going to use them. I don't care. So if you need really one thread per user, because you can't not split it up, then maybe it's not the best. But that's really seldom, to be honest. Advantages, there are some. You don't have zombies. In multi-threading applications, it could be the case that the thread gets abandoned for some strange reasons. So it still takes the resources, it's still blocking the CPUs and the cores, and it does nothing, and you can't even kill it anymore. It's a zombie, it's there. You cannot get deadlocks, because we have, in most cases, only one person who is going to take the resource. In a multi-threading application, you would have multiple who are trying to get the resource and putting a lock on it, and if another had already put a lock on it, and you want to get that, it's pretty hard if you have the lock for the other file, which the other one uses. So deadlock situations are really bad and can happen really fast. And yeah, you don't have that. Fast switching between input and output, it's actually because it's always event-based. So she always reacting on all things, they are there. And at least for me, I find it easier to scale it. I always been in multi-threading applications, big Java applications, where I was like, okay, how am I going to check out if I need to add more? When do I know that? Because I do not know how much threads are there and how they are working at the moment. So, yeah.
Yeah, and when we get that out of the way, one of the arguments that then comes up is, but I can build a small REST application a lot faster with, I don't know, Java, for example. So let's make a counter-argument and write an actual JavaScript backend. And, well, what we need to do in the beginning is, of course, define some stuff, import some stuff, and then start the connection. And let's assume we have like a small beverage store and we sell like coffee and tea and we serve water. And for now, we only want to concentrate coffee because it's the morning and I'm tired and coffee is great. So what we need to do is, of course, we have a get function and say we want all the coffees. And what we do is we just read all the coffees from our database and return all the coffees. Of course, we then need to listen on our port, and that's all. We're done, which is very quick, it's very small, and it's quite neat, right? So the argument, hey, but I'm a lot faster when I do it with X, Java, whatever, not valid. And we have some very nice advantages. It was quite small. I mean, it fit on one slide, basically, and I hope it was readable. And there's little to no overhead, which is amazing. But then, of course, people come like, there's no types. Like, no types? Really? I mean, we can just combine Express with this little thing that you might have heard of, which is called Typescript. And again, we can build a small little backend, and what we need to do for that is, of course, Christina is a tea person, so besides
finally
coffee, we also want to have tea for our customers. We define our tea, we give it a nice little name, we give it a type like black tea or whatever, we give it a steeping time because that's important for people that like tea. And at the end, we of course need to export it so that our services can access it and use it. And the next thing we need to do is, of course, make the tea available for our customers to get. And we do basically the same thing. We connect, we scribe our get method, we connect to the port, and we're done. Now we have a nice little backend that also has types. And when it comes to the advantages, it's similar to the backend we had before, with the added bonus of we have types. That's what we wanted, right? Still, everything is quite small and quite neat, and it's quickly written. And then people come along and say, yeah, but now I got to do everything by myself.
Really? There are frameworks for that. For example, there's Nest, which gives you a really predefined way how you could implement a REST application. They do have some core fundamentals in that. They have objects, that's everything which is holding data, for example, our tea or coffee classes. And on top, there are providers. Providers are like repositories or services or helpers, things which always can be injected or can inject other services. So they are more like the high-level interface which provides you with data and can do some stuff. And then we need still something which can communicate, for example, via REST, and that's done via controllers. And yeah, that's actually the core fundamentals. You have a controller in most cases for a REST application. This is probably talking to some kind of service. In our case, when we have a database, it would call a repository service or a data service, which gives us the corresponding objects from tea or coffee back. And we can actually group them in models. We can have more models. And how do we know how the app knows which models it can use? It has a main model for that. So that's actually the core fundamentals about that. So we make an object. In our case, we are going to use a MongoDB object for that. We create a provider. There's an injectable annotation over it so that we're telling them, hey, this provider can inject stuff, but also can be injected by other services and other controllers. And yeah, this only returns teas, just one, the Earl Grey tea. Then we have a REST controller. You're going to see there's also again an annotation. They are doing really much with the annotation currently. And there's one for a get, which is actually only calling the tea service. And you're going to see in line 3 that we are going to inject the tea service. So how does the controller know that there is a tea service? It actually knows that from the model description. You're going to see their imports, so you can import other models. You can import controllers, our tea controller, and you can import providers so that all controllers or providers know, hey, I also can inject this one in this model. And we need finally to define our app module so that the app knows which models are there. We just have one, our tea model, so we're putting it inside. And there's one thing we need to do. We need to start the server. Without, nothing happens. So let's do that. We're going to add the server, we're going to create it and start it, and we're finished. Yay! Okay, there's one big disadvantage. It's more overhead. you get more predefined stuff. That's the main reason why you have more overhead. But there are also some nice predefined stuff which you maybe want to use. There's something for caching, something for sockets, there's inclusion for GraphQL and Mongo. You can have security, for example, over Helmet for the HTTPS. There are some kind of authentication strategies for BEERS, JWT, OAuth. So there's kind of predefined stuff. If you don't want to define the libraries by yourself, that might be a good solution.
Yeah, and then people come along and say, yeah, but you really can't maintain a JavaScript monolith. And the reaction is, so what? This is not the JavaScript-specific problem. That's the problem with every monolith. And of course, then what you want to do is you want to get rid of your big, mean monolith, and you want to split it up in a lot of friendly little services. But in the talk before, we already heard that this is a difficult thing to do, and it's a long process, and it's a lot easier to talk about it than actually do it. But still, in the end, in my opinion, it's a lot better to get bitten by one of the small, cute little dogs than the big, mean one. Like, seriously, it's going to hurt a lot more. So, bye-bye, monolith. And last but not least, there's not a prejudice left, but a small love story. Streaming. Streaming in JavaScript is amazing, right? Yes? No? Maybe? Let's have a look at it. Now that I ate all my, I don't know, how many cinnamon buns did I have now? 80? Many. After I ate them all, I'm very, very thirsty. So, of course, I scream like, bring me some water! And after I defined some stuff and connected, when I scream for water, my socket will realize, okay, she wants water. So it tells, hey, please, serve her some water. And when we actually listen, our WebSocket gateway will realize that there needs to be some water served, and it will take care that I get some nice and sparkly lemon water. And now that we have built some small JavaScript microservices, we also need to talk about some more general things that you should keep in mind when building JavaScript backends, and especially a whole microservice JavaScript infrastructure.
Yeah, the first thing is about scaling. We have two different kinds of scaling. We have the vertical scaling, where we're going to add more machines to our environment. And we have the horizontal scaling, which is actually we have one machine and we add more resources like CPU or RAM to it. So, the first one is actually pretty easy. We must do nothing for that, because when we add a new machine and put their node server on it, it's just working. If we adding more CPUs, then, as we have previously heard, you need to do a little bit more for that. So that's not out of the box. But you can do that with that JavaScript. Also, which you should always take a look on, is logging and tracing. So we have here, for example, our first service, which is talking to the second service. The second service is talking to the third service and to a fourth service, and the fourth service is talking to another service. And at some point, we are going to get an error. Nice. But we get it in the log, so cool, we do have something. But I can't figure out why this service is failing, because everything looks right. Maybe this one isn't the problem. Maybe this one is the problem. So maybe it does give me something back which I can't work with. Maybe it says, yeah, you give me the wrong parameters, I can't work with that. And then, oh, wrong parameters. Could it maybe this one, because he's on before that? Maybe he gives me already the wrong parameters? Or the other two, I don't know. And with tracing, you can follow your complete request and know exactly, okay, this service is the fault. And not actually the one which is saying, no, I can work, I'm failing at the moment. So tracing is really important. Stateless. Services should be always stateless. Why? Or at least somehow stateless, the most of them. We have, for example, here a service which is talking to a database. And how are we going to replicate it? We could put a second service with the same database below and mirroring the database, but synchronizing databases isn't fun, not at all. So maybe we could do something different. Oh, yeah, we could have the same data. So let's use the same database. But again, transition management, when we have too much resources so that we actually need to split the database, or did too much request, or all of these things, it's not so nice. So if you can avoid it, try to avoid it. You cannot come around of it, but try to keep it less. And the most services should be actually stateless to avoid this kind of problems.
So now that we have a couple of services, we of course probably have some sort of library or some sort of common service that all the other services need to use. And updating that one library is not good. I've been in projects where we had like the side menu. It was a different service that was being written, and every time this library got updated, every other view needed to import the new library. And of course, some teams were a little bit slower or didn't do it or didn't get the notice. And then the users and the testers were complaining that the behavior is different and some links are missing, and it's just a mess. So try to build your services more independent, but of course there's also tools that take care of all those updating libraries for you. And while we are on the topic of updating libraries, security. Yeah, it's a mean thing, but especially when you have microservices that are sending data back and forth and user data and whatnot, you of course should do things like encrypt data and control access, and of course keep your dependencies up to date and yada yada yada. Talking about microservice security is a whole other topic, but seriously, you should do it. It's important. And I know from experience that a lot of the time security is pushed back to the project, but of course when you're at the end of the project, there's a deadline and no time and no money, and it can end very, very badly. So please take care of it. And besides security, of course, reliability is a very important thing, because especially when it comes to error handling and users being angry, it's not going to end nice for the team. And what can help with it is, of course, testing and this thing like chaos engineering. In the beginning, we mentioned Netflix, and you might have heard of the Simian Army and the Chaos Monkey that Netflix is using in order to try to find weak spots in their infrastructure and in their programming. And chaos engineering can be very, very helpful with making your application more reliable. And what's also helping with keeping your application happy and healthy is health endpoints.
Yeah, why? Because if we are going to deploy our server on something like Kubernetes, Kubernetes is using these health endpoints and asking, hey, are you alive? And hopefully the server is going to answer yes. Oh, yeah, he did it. But at some points, he's going to say no, or even not react at any moment. So it's more like a timeout, and you're like, oh, he's not responding. So I think probably he's dead. So what are we going to do, or what does Kubernetes in this moment does? It's going to kill the service and restart the service. And then we're waiting until the service is there and the readiness is there. And hey, we have a new service instance and it's running all again. So we don't need to manage this by ourselves. There's something which can do that for us. And actually, you could do it, for example, with a middleware, which you can write yourself, where you implement the health endpoints, but also there are frameworks for that, which you can use, Terminus, Lightship, and these are then providing you the health endpoints, and you can customize them if you want to. Also, really important properties. We have here our nice database string, and I already see some stuff like a username there, and ooh, a password.
That's non-encrypted in the best case.
Probably. And maybe there's some parts which you want to configure, and that's actually parts which do not belong hard-coded in your code. Because when you want to configure it, you need to redeploy the complete application. Yay, funny. So what are we going to do? We're going to put them in the end file so that tools like Docker, Kubernetes, and I do not know which are there on the market, can override these properties and customize the values behind that. And yeah, I think you all know that .env, so I'm not going to cover it, but there are tools and libraries which you can use for that again. So what is actually the main goal of our talk? We just want to say, there's more beside the things which most people have in their head about backends. You can do that with JavaScript. And it's up to you. Take the best tool, take the best language which is suiting you the most for your application. So maybe it's also JavaScript. So then do that. So that's actually the end of our talk. If you have any question, you can talk with us. We are there today and at the party later.